So least square method for a straight line and parabola. For a straight line, we are getting these kind of equations. These are two equations. Okay, summation of yi equal to na plus bxi. And in the same equation, like I told you in the previous class also, you can recall this equation. You know the equation of the straight line, y equal to a plus bx. So this is what summation of yi equal to na. N is what number of variables, number of data points. Na plus b summation of xi, I equal to 1 to 1. Okay. And second equation, just multiply xi in this equation. Okay. So summation of xi yi plus a summation of xi. This n will not be there. Now you are getting summation of xi. Before it was a constant, adding n time constant. That's why we are getting na. Otherwise, we are getting in the second equation a summation xi plus b summation of xi square. These are two normal equations. These equations are called normal equations. Okay. After solving these two equations, you get the value of a and b, and then you will get a best fit of the form y equal to a plus bx. Okay, so this straight line will give you the best fit through the given data points. So this is for a straight line. Now, second thing is what? For the parabola that we discussed in the last of the class. So parabola is what? You know the n data points are available, and data points are available. Then you can keep remember these equation like summation of what is the equation of the parabola. Equation of the parabola is what, or the quadratic equation is a plus bx plus cx square. So you can write summation of yi equal to this a single, that's why na plus b summation of xi square plus c summation of xi square. Okay, just keep remember this is I is varying from 1 to n. I'm not writing again and again. Okay, 1 to n. So this summation means this summation is for I equal to 1 to n. So y1 to yn. Second equation will be what? I should write y. Second equation will be multiply xi to this equation, xi yi equal to a summation of xi plus b summation of xi square plus c summation of xi cube. Third equation, again multiply this equation with xi. You are getting xi square yi plus equal to a summation of xi square plus b summation of xi cube plus c summation of xi 4. So these are the three equations, three variable. Solving this equation, you are getting the value of a, b, and c. Solving equations gives you the value of the values of a, b, and c. After putting this value into the parabola equation, you will get a best fit parabola passing through the given data point. So it depends what kind of data you are having, and accordingly you will choose what you have to fit, whether it is a straight line or a parabola or cubic equation. It depends. So let's do one example based on it. Suppose data points are given to you and you have to do what? You have to fit a second degree polynomial to the given data. So the data points are what? X and fx. So for -2 value of the function or y, we are taking as 15 minus 1 equal to, at -1 value is 1, 0, 1. At 1 it is 3, and at x equal to 2, the value is 19. So this is x is called independent and y is called dependent variable. After that, if you see, what you have to do, you have to fit up a second degree polynomial. So you know the equation of how to compute this second degree polynomial with the help of these three equations. So what you require? Summation of yi, summation of xi, summation of xi square, xi cube, xi4, and xi yi and xi square yi. So how many things are required? 1, 2, 3, 4, 5, 6, 7. So you have to form 7 tables. So first you will compute x square, x cube, x4, xi yi, and xi square yi. And after that, you have to find out sum of all these values. Okay, so summation of x is what? -2 minus 1, and you are having the same positive value. So the summation of xi is coming out to be 0. summation of yi, sum of all these values, summation of xi square, that is 10. So similarly, you are getting all these values and you have to put all these values into these three equations. Okay, so you are getting three equation and three variables. So summation of y I equal to na plus b summation of xi plus c xi square. So summation of yi is what here? That is 39. 39 equal to na. How many data points are here? 5. So 5a plus b summation of xi 0 plus c summation of xi square. Summation of xi square is what? That is 10. So this is equation number 1. Second equation will be what? Second equation is summation of xi yi. Summation of xi yi is what? This is 10. So 10 equal to a summation of xi 0 plus b into summation of xi square. Whatever you are having, that you have to make, right? X square, xi square is what? 10. Also 10. Okay. By chance, xi yi is also 10 and xi square is also 10. Okay. So plus c xi cube. So xi cube is what? This is the value 0. Okay. This is equation number 2. Third equation is what? Summation of this value is what? This is summation of xi yi. Okay. Summation of xi square yi. So this value you can check from here. That is 140. So 140 equal to a into xi square. Xi square is what? This is 10 plus b summation of xi cube. Xi cube is 0 plus c xi 4. Xi 4. Xi 4 is what? 34. 34. Okay, solving, you have three equations, three variable from the second equation, from third equation, sorry, from second equation, you're getting value of b, it is coming out to be 1, 10 upon 10. And value of first and third equation, you are getting the value of a and b. A is what? Minus 37 upon 35, and the value of c is coming out to be 31 upon 7. Okay, solving these equations, we are getting these values. So a plus bx plus cx square with these values will give it the second degree polynomial that is fit in with like in this data. Okay. So one more example. This is the example of example for the function. With the help of least square method, we can fit a function to the given data. So here the form of the function is given to you. Least like a function form is given here, y equal to a raised to power x, a into x raised to power b. So what you have to do, you have to fit this function in this data. So data is what? For these x values, y values are given. So how to proceed? So if straight line and parabolic part is clear, then it's very easy to understand this example. Okay, so function is what? Y equal to a raised to a into x raised to power b. We will try to write this equation into the known form. Known form means what? Either in term of a straight line or in term of parabola. So y equal to a raised to a into x raised to power b, taking log of this equation, because we want to simplify this form in term of some known form. So whenever we will take log, so what we are getting here log y equal to log a plus b log x. Okay. Log y, that is the function of y. So we can write it as capital Y. Okay, some other form. So this capital Y is what? Small, log into log of y equal to log a is what? That we are taking a constant capital A, and this small b we are taking as capital B and log x. So this is what? This is the form of the straight line. And you know how to fit a straight line to the given data? Okay, we will proceed in the same way as we did for straight line. Okay, so capital is what? That is log A. Capital B is what? Small b. Capital Y log y, and capital X is what? Log x. So how to do that? Okay, So you know the procedure how to fit a straight line that we have discussed already in the previous class, or let's recall again. So you can write it like that. Error is what? Yi minus abxi. So yi is what? Now you have to fit a straight line in terms of the variable capital Y and capital X with the constant capital and capital B. So you know already like how to fit a straight line. Only in terms of a small y or small x we are having capital Y, capital X, nothing else. You are getting same kind of equation. So summation of yi equal to na plus b summation xi. So you are having here 4 data points. That's why n is equal to 4 I am using here. Plus b summation xi and summation of xi yi equal to a summation xi plus b summation xi. So you have not to show these things. You can directly write these normal equation for the straight line. Okay, now what else is required? Summation of yi, summation of xi, summation of xi yi, and summation of xi square. For that, we will form a triangle. It should be clear what is capital Y. Capital Y is log of small y. Okay, so we will do like that. These are the data point for small x, data point small x and y. So small x value is this, y is this. Capital Xi is what? Log of xi. And capital Y is what? Log of small y. So these are the value we are getting. Now next is what we want, like in order to apply this formula, we require summation of xi yi into xi square. So we can form these values in table. So xi yi into xi square, these things. And after that, we have to find out the sum of these values. We computed and just put these value into this two equation and get the value of capital and capital B. Solving these equations, like put the value capital X and capital Y, xi yi into y square. Solving this equation, we are getting the value of capital and capital B. Okay, so capital A is what? I told you, log of A. So if you want to get the original value of A, so it will be what? E raised to power capital A. So that we have done here. E raised to power capital A. Capital A is computed like that. And then get the value small a, this value, small v is this value, and then we are going to the original required function. So that is what a x raised to power b. So small a is this value, small v is this value, put here, and then you can get the form of the like function that is fitted in the given data. Okay, so like a is what? 7.3787, x raised to power 1.9303. So this is the function we fitted to the given data. Okay. Similarly, some more question can be asked. Like in notes, I have written 2 more questions of this kind of that we will send you. Next thing, one more thing is here. Okay, just a minute. I just want to write one more example. I'm not going to do that example complete, but I will give you an idea of it. Okay. Suppose some fit a curve example. Fit a curve of the form y equal to ax plus b upon under root x. So what is given? Fit a curve of the form y equal to ax plus b upon under root x to the given data. Data आपको क्या given है? X is 0.2, 0.3, 0.5, 1 and 2, and y is given as 16, 14, 11, 6, 3. So these data points are given to you. What you have to do, you have to fit a curve of this form. So what you can do, you can write this equation in the form of a straight line or parabola. It depends what type of equation given to you. So since the equation is given here, ax plus b upon under root x. So you can write it in a simplified form like that. Y equal to ax plus Actually A is already given to you. So what you can take is as C1x plus C2. So C1 is okay. So C1 is bought, that is capital A, and C2 is bought, that is B upon under root X. B upon under root X. Okay. B upon under root X. So you will treat C2 as constant and X is as variable. So what you can do, you can just form a table of the form. So it's up to you how you are writing. Otherwise, you can also proceed like y under root x equal to a x under root x plus b. Okay, you can treat as capital Y equal to this thing you can take as capital X and A and B as it is. So it's up to you how you proceed. You can do Y this way or Y this way. Main thing is what you will try to write function form in terms of a straight line or a parabola, depend what is the degree of the polynomial. Okay, so what you can do, you can write here a small x, a small y, and then y small x under root x that you are taking y under root x. So in the original form, this capital Y will be treated as y under root x, and capital X will be treated as x under root x. Okay, then you will form this xy is used only to compute the value of capital Y and capital X, and then you will fit a straight line with the help of capital X and capital Y. Okay, have any doubt, then discuss. Okay. Any doubt, then ask. Otherwise, I'm proceeding. So you have to do this question by yourself.
Ma'am, good morning, ma'am.
Yes, good morning. Any doubt in this question?
Yes, ma'am.
Yes, ask.
मैम जो हमारा कांस्टेंट है b, उसमें आप कह रहे थे कि हम c2 को b by root x भी ले सकते हैं, जैसे कि आपने यहाँ पे किया।
या तो आप या फिर इस तरीके से करेंगे, यू कैन।
ठीक है मैम, लेकिन हमारा c2 तो कांस्टेंट है, तो बेसिकली उसमें मेरे को लगता नहीं कि x की टर्म इन्वॉल्व कर सकते हैं, कि कर सकते हैं?
नहीं कर सकते
हैं?
नहीं,
अच्छा नहीं कर सकते ना ये, ठीक है, वही पूछ रहा था।
नहीं कर सकते हैं, we should do by this one. Okay, so you should do this question by yourself. I will do solution also. So next is what? So this list square portion is done. After that, one more thing is left. In a Newton divided difference, there is one statement or one result that is very, very important. I was thinking to complete after the completing the Newton forward and backward, but I forgot to do that. But I'm doing this now. This result is for what? It is for finding a relationship between Newton divided difference and derivative. So Newton divided difference is having some relationship with derivative. What kind of relationship? Let us explain with the help of this statement. F is a function belonging to C and AB. C and AB का मतलब क्या है? This function is n time and a derivative of the function is continuous inside the interval AB. And a derivative of the function is continuous inside the interval AB. That means and a derivative of the function exists inside the interval AB, and that is continuous. Okay, x0, x1, x2, xn are distinct number in AB. Then show that there exists a number xj or any function, any number. If you have doubt, you can take any variable. Okay, I am representing it with the help of xj belonging to the interval AB such that f of x0, x1, x2, xn. So nth order derivative, nth order divided difference, nth order divided difference can be written as in term of nth derivative of the function at some point that is different from x0 to xn upon factorial. Okay, but this xj is belonging to the interval AB. So ये जो xj है, that is different from these endpoints, where it is clear what does it mean. Okay, so there is a relationship between Newton divided difference and the derivative. Okay, so Newton divided difference of order n is equivalent to nth derivative of the function upon factorial n, and that nth derivative exists, or nth derivative is defined at some point inside the interval AB different from x0 to xn. Okay, let's prove it. It's a very simple proof, but sometimes proof is asked, like if you see previous year papers, then either EST or MST, this question is asked. Now you're not going to give MST, so there's low chance, but the application based question can be asked from this result. Okay, but if there is EST, then there are always a chance to get this kind of question in EST exam. Okay, next is, let us prove this result. It's very simple. For that, for proving this result, we will define a function gx that is equivalent to fx minus px. Fx is what? That is some data value of the function. Fx is what? That is the data function, that is the function. And px is a polynomial passing through the given n plus 1 data points. ठीक है ना? तो fx जो है वो एग्जैक्ट वैल्यू है, px जो है वो हमारा इंटरपोलेटिंग पॉलिनोमियल है जो कि अप्रोक्सीमेट कर रहा है फंक्शन को. So fx minus px is what? It is equivalent to some error. That error we are defining as gx. Okay, so px is an interpolating polynomial, and if it is this px is a divided difference interpolating polynomial, then we can write px in terms of this formula that you all know. So fx0 equal to x minus x0, fx0 x1. So this is the form of Newton divided difference interpolating polynomial. Okay, now next is what? Okay, gx is what? Fx minus px. You know the property of interpolating polynomial. What is the property of interpolating polynomial? At xi is what? Given data points. Okay, x0, x1 up to xn. Polynomial value is equivalent to the function value. So this is the property of the interpolating polynomial. Yeah. So g of xi will be what? It will be 0 at these point, because x0, x1, x2, xn पे जो function की value और polynomial की value same है. So that's why whenever you will put the x equal to these points, so you are getting value gxi is equal to 0. So g, what does it imply? This implies that gx is 0 at x0, x1 up to xn. That means n plus 1 data points. है ना? gx जो है वो कितने points पर 0 है? n plus 1 data points पर 0 है. Okay, so there is a theorem, Rolle's theorem. एक बार हम Rolle's theorem को recall करते हैं. What is Rolle's theorem? If a function fx is continuous inside the interval a to b, differentiable in the open interval ab, and f of a equal to f of b equal to 0, then there exists a point C belonging to the open interval AB such that f dash C equal to 0. So this is your Rolle's theorem. This is Rolle's theorem. Okay, there is a generalized Rolle's theorem. Generalized Rolle's theorem. What is generalized Rolle's theorem? Generalized Rolle's theorem is what? If x0, x1, x2, xn are the point inside the interval, and f of x0, f of x1, Same condition. Fx is a function continuous inside the interval AB, differentiable inside the interval AB, and f of x0, x1 up to f of xn is equal to 0. इसका मतलब क्या है? f अगर n+1 डेटा पॉइंट्स पर 0 है, then there exists a point, that is suppose Rx, belonging to the interval AB. This Rx is different from these points such that the derivative f n+1 data points 0 पर ये 0 है, then fn, यहाँ पे आपके 2 points पर 0 था, then there is first derivative. When f is 0 at n+1 data points, that fn Rx is equal to 0. This is generalized Ro's theorem. अगर 3 points पर 0 है तो second derivative will be 0 inside the interval AB. Okay, if n+1 data points per 0 hai, then there exists a point Rx belonging to the open interval such that fn Rx equal to 0. So this is generalized Ro's theorem. By using this Ro's theorem, we will prove our result. Okay, so gx is 0 at n+1 data points. So we can write it. Same thing. I should write. Gx has n+1 distant 0 in AB, then 1 by generalized Ro's theorem for the function g inside the interval AB, there exists a number Rx or xj, whatever you want to write, belonging to the open interval which satisfies this condition. Okay, by the generalized Ro's theorem. So gn xj is equal to 0, and we have already written here gx equal to fx minus px. Px is a polynomial degree n maximum. So g of n, just write x as xj. It will be what? F of n xj minus pn, and a derivative of the polynomial xj is equal to 0. Okay, so we can write this value is equal to 0. When it is equal to 0, then fn xj equal to pn xj is equal to 0. And you know px is what? Let's go back and check what is px. Px is a polynomial of degree n. If you differentiate this polynomial n times, what you are getting? Px is a polynomial, and what is this term? This is a polynomial of degree n, है ना? ये क्या आएगा अगर हम x minus x0, x minus x1 एक मिनट में लिखते हैं. If we are writing x minus x0, x minus x1, what we are getting? X square plus some value x plus some value. ठीक है? अगर हम दो पॉलिनोमियल का मल्टीप्लिकेशन लिखते हैं सिंगल डिग्री, तो we are getting x square some coefficient x with some coefficient and constant term with some coefficient. Okay, if we are writing three terms, x minus x0, x minus x1, x minus x2. Okay, three terms है और यहाँ पे 2 है. So you are getting some constant, don't get confused with 0. This is some constant, x cube plus some constant, x square and so on. So similarly, if we are writing x minus x0, x minus x1, x minus xn, sorry, xn minus 1, xn minus 1, 0, 1, 2, 3 degree polynomial. 0, 1, 2, n minus 1. It is a n degree polynomial. Constant xn, some constant xn minus 1, and so on, some constant term last. Okay, if we are differentiating it, okay, let's start from here. We are differentiating it 2 times. What you are getting? X square को 2 बार differentiate करेंगे तो आपके पास आएगा 2 into 1. अगर हम 3 times differentiate करेंगे x cube को, what we are getting? It is coming out to be 3 into 2 into 1 factorial 3. If we are differentiating it n times, it is coming out to be factorial n, because जो भी छोटी terms है वो cancel होते जाएंगे ना. n minus 1 x raised to power n minus 1 को n time differentiate करेंगे तो वो 0 हो जाएगा. So you are getting factorial n. Now we are going to use this term. Have any confusion? That is okay. So we are getting Pn xj. Pn is a polynomial of degree n. So उसका जो coefficient है है ना, ये टर्म है, you are differentiating it n time, dn over dxn. So dn over dxn. So what you are getting? It is coming out to be factorial n, and this term will remain as it is because it is a constant term. है ना, जो table, this is a tabular term, that is a constant. So factorial n into this value, f of x0 x1 x2. So this is the thing written here. So fn x, so we can write this value f of x0 x1 x2 xn equal to fn xi upon factorial n. So this is the result we got. So it's very simple. What we have done in this theorem, in order to compute the relationship between Newton divided difference and derivative, we have started with some function that is gx equal to fx minus px. Px is a polynomial passing through the given n plus 1 data point. And then we apply generalized Rolle's theorem. Okay. How we apply generalized Rolle's theorem? Because we know the property of interpolating polynomial, that fx and px are same at the given n plus 1 data points. Okay. So that is that thing we used, and then we apply generalized Rolle's theorem. That's why we are getting this condition. From here, we are getting these three steps. So this is the theorem. Okay. Have any doubt? Ask. Otherwise, I'm going to discuss an example based on it.
हम वो लास्ट स्टेप कैसे आया, वो जो रेड लाइन में लिखा है?
ये वाला?
अच्छा, समझ गया, ठीक है.
ओके. किसी और को कोई डाउट हो तो पूछ लीजिए. इट्स वेरी सिंपल बट बहुत यूजफुल है. Okay, so there is one example that I want to discuss here. ये क्वेश्चन शायद आपका ट्यूब शीट में भी है. एक जो मैंने क्वेश्चन इस पर बेस डाले हुए हैं उसमें भी है. Show that f of x0 just a minute. I'll wait for 2 minutes. Show that f of x0, x1, x2, xm is greater than 0, where f of x6 e raised to power x. Okay, where for example x0, x1, x2, xm are distant point. Nothing is given to you, only it is given like you have to show that the mth order divided difference is greater than 0. So how to proceed? If you know the relationship between f of x0, Newton, if you know relationship between the, I'm writing this here, xi I should write. Factorial m. If you know the relationship between the divided difference and derivative, then you can do this question, otherwise you cannot. Because the function is given to you, e raised to power x, and m at derivative of ex will be what? It is ex upon factorial m. And you know the exponential function is always greater than 0. That's why we can say from here, this is f of x0 up to xm is greater than 0. So that's why this question can be done, otherwise not. Okay. So it's a very good example of this theorem. Is example is this is the best example of this theorem. Okay. One more thing. Sometime you have to compute RR in polynomial, maybe in Newton divided difference of Lagrangian, and you know the function, then you can use this theorem to compute derivative. Okay. So this portion is done. जो आपका ये इंटरपोलेशन है ये खत्म हो गया. इसके बाद में हमारा जो नेक्स्ट टॉपिक है that is integration, that will start in the next class. Okay, I want कि आपका जो ये है क्या नाम है, दिवाली से पहले इंटीग्रेशन चैप्टर पूरा कंप्लीट हो जाए. वैसे आपके पास 5 लेक्चर है, बट दिवाली के बाद में भी एक दिन का मुझे हॉलीडे लेना है, लाइक ऑन ट्यूसडे like 17. So I will take one more extra class before Diwali, so that portion will be completed. ठीक है. अभी किसी को कोई डाउट है तो बता दीजिए, otherwise I'm ending this meeting.
Thank you, ma'am.
Okay.